In this video, I will be going over how to use Descartes' rule of signs and what it tells us about a polynomial or any general equation. So here, we're going to start off with a quadratic. X squared minus 3x plus 2 is equal to 0. We're going to factor this out to see our solutions, where we get x minus 1 and x minus 2, since we are finding two numbers that multiply to positive 2 and add up to negative 3, and these are our two numbers. So now we see that we have two positive solutions, so we have x is equal to 1 comma 2. But we want to see if Descartes' rule of signs tells us that we have two positive solutions. So first, we're going to start off with a table on the right. And we're going to have positive on the left, negative in the middle, and complex solutions on the right. And here, we're just going to look at the sign changes of f of x, which is equal to x squared minus 3x plus 2. And here we see that the leading coefficient is positive 1, since there's nothing in front of the x squared, so we see that it goes from positive to negative. So there's one sign change. And we go from negative 3 to positive 2, and we see that there is a second sign change. And we see that we can't go on further because there's nothing there. So we see that we have a possibility of there being two positive solutions. And since Descartes' rule of signs also states that if we have an even amount of positive solutions, we should subtract 2 in case if we don't have those two solutions. And here we are going to go ahead and look at the possible negative solutions, but for our first table, we see that there already are two positive solutions, and a quadratic can only have two solutions. So we have 0 negative and 0 complex. And to find the negative solutions, now we just have to replace f of x with f of negative x, and we just plug that in. We get x squared plus 3x plus 2. So now we just look at the sign changes and see that there are no sign changes. There are none. So we have positive to positive, so that means that there's 0 sign changes. So we write 0 for our second column. And since we see that there are 0 positive and negative solutions, that means that we could have a possible outcome where we get two complex solutions. And the reason we have two tables is because, for example, if we have x squared minus 3x plus 100, that is going to be above the x-axis, which is going to have a y-intercept of 100, and it's going to look something like this, which has no real solutions. That's why a quadratic that has plus, minus, plus could either have two real solutions or two complex solutions. And as we see here, our first table is correct, suggesting that we do indeed have two positive solutions, since our two solutions are positive when we factored our equation. So let's go ahead and look at a cubic now and see how it acts. So here we have x cubed minus 6x minus 9 is equal to 0. Let's go ahead and make the table on the right. Here we're going to have positive again, negative, and the complex solutions. now we are going to look at the sign changes for positive solutions. So we have one sign change and then no sign change. So that tells us that we have one possible real solution. So now we have to go ahead and look at f of negative x to see if there are any negative solutions. So we just plug in negative x for x, and we get that we have negative x cubed plus 6x minus 9 is equal to 0. So here, now we have that there is one sign change, and there is a second sign change, so we have two changes in total, giving us that we have either three real solutions, but they're all distinct, or we have one positive solution and 0 negative solutions. And since we have the top being 1 and 2, and we have a cubic, we could have a total of 3 solutions. So this is already giving us 0 complex, and for our second row, we get that we have 2 complex solutions. So which of these do you think is correct? The first row or the second row? Let's go ahead and find out. So this cubic could be factored by using synthetic division. So let's list the possible factors of 9. We have plus or minus 1, plus or minus 3, and 9. So let's go ahead and use positive 3 to be the number we divide our equation by. And we are going to go ahead and drop 1 straight down, multiply by 3. And 0 plus 3 is positive 3. And multiply 3 times 3 giving us 9. 9 minus 6 is 3. 3 times 3 is 9, and that is equal to 0, giving us x minus 3 times x squared plus 3x minus, or no, that's plus 3. And that is our quadratic. And seeing this now, we can go ahead and try to factor it out. And if we try, we see that there's going to be no real solutions that make this equation true. So we're going to use the quadratic formula, giving us x is equal to negative 3 plus or minus the square root of b squared, which is 9, minus 4 times AC. 4 times 3 is 12, all over 2a. We just simplify this. We have negative 3 plus or minus the square root of negative 3 over 2. And our final result is negative 3 plus or minus I root 3 over 2. So we get that our answers tell us that the second row is correct, since we have one real solution, which is positive, and the other two that are complex. So we see that Descartes' rule signs does work, and it actually tells us or gives us an idea of how many solutions there could possibly be. So let's go ahead and look at another example, and we'll wrap that up for this video. So the next example we are going to look at is x to the power of 5 minus 4x cubed minus x squared plus 4 is equal to 0. So let's go ahead and start off by making our table and identifying how many positive and negative solutions we have. So here we have positive, negative, and complex solutions. So let's count the positive sign changes first. So we have positive to negative, and negative to negative, and negative to positive. So that means we have one sign change, then 0, then a second sign change, which is 2 in total. And we're going to subtract 2, so we have 0. And now we're going to look at negative f of x, which is going to tell us our solutions that are negative. So we're going to have negative x to the power of 5 plus 4x cubed minus x squared plus 4, and we're going to have one sign change, two sign changes, and 3. So we have 1, 2, and 3. So here we have 3 and 3. So here we are going to have our first row where we have real solutions that are all 5 of them. And here in our second row, we're going to have 0 and 3 negative solutions and 2 complex. Now we are going to go ahead and see if there's any more tables we could get from the negative 3. So these tables might not really work, but we have 2, 0, 1, 1, 2, and 4. But these rarely ever work, so we're just going to leave them there just in case. So now we are going to go ahead and try to factor this out. So we see we can group this and factor this out by grouping. So we have x to the power of 5 minus 4x cubed, x cubed, plus negative x squared plus 4. And we could just factor out a x cubed from here, x cubed times x squared minus 4. And we could factor out a negative 1. So we have x squared minus 4. And we can just factor this out, giving us x cubed minus 1 times x squared minus 4. And here we can go ahead and use the difference of cubes, which is u cubed plus v cubed is equal to u plus v times u squared minus uv plus v squared. So we're going to factor out our equation here, and we are going to get x minus 1 times x squared plus x plus 1. And we're going to have x minus 2 and x plus 2. So here we can solve for x now. We get x is equal to positive 1, which is one of our solutions. And we have 1 positive and 2 positive solutions. And here we have 1 negative. So here we basically see our solutions where we have x minus 2 and x plus 2 and x minus 1. So here we have we have 2 positive solutions, so we can cross out 2 of our rows. And since we have 1 negative solution and 2 positive, that basically leads us to say that our third table is correct. Because if we solve for x here, we get x is equal to -1 plus or minus the square root of 1 minus 4 divided by 2. And we have -1 plus or minus I root 3 over 2. So here we end up getting that we have 2 complex and 2 positive and 1 negative. So we have 1 negative, two complex, and 2 positive. So our third table was correct in suggesting that we have 2 positive, 1 negative, and 2 complex solutions. So that is that for this video, and I hope you enjoyed, and thanks for watching.